Hi, in the previous lesson, we named this as a point, this as a line, and this as a plane. We also defined them. By the way, what is a definition? A definition is a statement that explains or classifies the meaning of a word or phrase. With our understanding of what is a definition, we know the definitions of the terms point, line, and plane have words which themselves require to be defined. We defined line as a straight, continuous arrangement of infinitely many points. In this definition, what is straight? What do we mean by saying a line is straight? Therefore, these three terms, point, line, and plane, remain undefined, though they are the basis of all geometry. With these three terms, point, line, and plane, we can define all other geometric figures and terms unambiguously. These points A, B, C are collinear. That is to mean they are on the same line. These points D, E, F are not collinear because no single line can be drawn through them. So, collinear is defined as points on the same line. We use this notation to show collinearity. This means points A, B, C are collinear and point B is between points A and C. It is time to deal with some geometric postulates. A postulate is a statement that is assumed to be true. Here, we have 2 points, A and B. How many lines can you draw through these points? Remember, a point has only location, and a line is made of infinite points. As you have guessed, only and only one line. Here goes our first postulate. Through any two distinct points, only and only one line can be drawn. Phrased in other words, you can say 2 points uniquely determine a line. By now, you are familiar with the figure shown. How do we call it? I know you guessed a line, but you are wrong. A line has arrows at its end, indicating its extent forever, not points. We call this a line segment. Points A and B at its end are called endpoints. We name a line segment by writing letters A and B representing endpoints together, and then we put a bar over them. Now, we can define a line segment as part of a line having two distinct points called its endpoints and all points in between. Then, what is the difference between a line and a line segment? This is line segment AB. Now we have a point C between A and B. The measure of AC is 6 and the measure of CB is 4. What is the measure of AB? It is simple. You add the measure of AC, which is 6, with the measure of CB, which is 4, to get 10, which is the measure of AB. Now, we are given the measure of AB as 12 and the measure of CB as 5. How can you find the measure of AC? You know, to get the measure of line segment AB, we add the measure of these small line segments. That is, AC plus CB is equivalent to AB. We don't know AC, but we know the measure of CB and AB, which are 5 and 12 respectively. I will replace known variables in our equation. This will give us AC plus 5 is equivalent to 12. Then, I will isolate AC. To do so, I will subtract 5 from both sides of the equation, which will be AC plus 5 minus 5 is equivalent to 12 minus 5. 5 minus 5 is 0, and 12 minus 5 is 7. This simplifies to AC is equivalent to 7, which is the measure of AC. Here goes our second postulate, also called segment addition postulate. It states, if C is a point of line segment AB, then AC plus CB is equivalent to AB. Meet on the next lesson. Bye bye.